Let's talk about back volume. In this video, I'd like to give a brief overview of back volume and why we care about it, and how to calculate it in CAD. In this tutorial, I'll specifically be using Fusion 360. So, what is back volume? When we search for back volume, we aren't really presented with great results from Google, but when we slightly modify that search term to the amount of air for speaker performance, we get some results which are a bit closer to the definition of what we call back volume in the tech industry. Back volume is the volume of air held in the speaker cabinet. The speaker cabinet is the cabinet which holds and mounts the speakers on a consumer electronic device. This volume of air inside the cabinet can impact the bass response and can have a significant effect on the speakers. For example, speakers in an open cabinet tend to have weaker bass than speakers in a closed cabinet, encasing the back volume, for example. For most cases, the more back volume you have, the greater the bass response. However, from personal experience, there's typically a limit on the size of the back volume when correlating to overall bass performance output. What I mean by this is you can't simply put a woofer from, say, the Apple HomePod and put a cabinet behind it, which has as much back volume as, say, the volume of your bedroom or something like that. The performance limitation starts to become the speaker itself at that point, and not the amount of air you've given the speaker to fuel the bass. To utilize all the back volume, you'd need a larger speaker. Now that we've introduced back volume, let's jump into the CAD tutorial and open up Fusion 360. You can see the demo that I've prepared for this example. We have this big enclosure, and you can envision, say, like a big woofer is on top, and then, say, we'll just call these tweeters for the purpose of this example, as they live inside the back volume of this larger speaker. If I hide this housing, just come over here and say hide housing, we've got like a dummy MLB with some components on it, and a base like with a rubber foot. This is our back volume. So if I isolate this back volume, right click and left click on isolate, you can see that everything that is behind, say, the woofer and the back housing, that is all encased in the back volume of the speaker itself. And if we turn on the analysis, you can see that I've subtracted all of the physical portions of those bodies, including the speakers and the MLB and the foot at the bottom, to come up with the back volume. This workflow is going to give us just that. And what I've actually done is, if I hide this, actually if I unisolate it and show everything else, including the housing. So this subassembly I've actually exported and thrown over to this GrabCAD link. So this is just my personal GrabCAD file. It's actually the first time I've used this in a Fusion 360 tutorial. So you could follow along directly. Go ahead and download these files, and I'll leave a link below. You go ahead and open this up. You'll have something that looks something along the lines of this when you open it. Now, the first thing we're going to do is go up here and right click, new component, and in the naming, we'll just say back volume. Hit enter. Great. The overall approach, at least how I calculate back volume for consumer tech products, is I create an overall body, and then I subtract all the other components that I want the body to represent. Basically, what we want at the end of this workflow is a body that is the subtraction of all the other components in this audio acoustic system, and is essentially just representing the air that the audio system can represent. Let's go down here and left click on back volume and left click on activate, and we'll just create a sketch. Left click on this plane here at the very, actually, let's make sure. Left click at the very bottom and do sketch. C for circle, right at the center point here, we're gonna make a circle that goes all the way over the entire device. Right click, isolate, extrude. There we go. Let's just do that for now. We'll click OK, and then we'll unisolate it, and then it's only halfway up. But we want to bring this extrusion all the way up above and beyond the surround of this woofer up here. So right click, edit feature, and we'll just drag it all the way up. Click OK. Now, a good way to understand or see what we're doing here is to go over to inspect and then select section analysis. I already have one, but we'll just add one, say, on this front plane. You can select OK. And if it doesn't appear, you might have your analysis off. So going over here to the tree and left click on to make it visible. All right, so one of the first things we want to do just to kind of differentiate this from all the other components, because it's kind of hard to tell, is right click on the back volume body and go left click on appearance. And we could just, typically I like to do like blue. So just search for blue, maybe grab this aluminum anodized rough material, and we can just drag and drop that by holding down the left mouse button and go into the body. And click close. And just to make sure that worked, we can right click and do isolate. And we've got this nice blue looking body here. And we'll right click and unisolate. All right, so that is the first step. Now what we're gonna do is the subtraction of the rubber foot. So the back volume is only, at least in this view, encompassed in this yellow, you can call it, I know I referred to it as a cabinet earlier, but sometimes you can have a cabinet or a housing that are both inside the back volume or encasing or enclosing the back volume. So we'll just assume that our housing out here is also our cabinet. So in order to do that, we can click on combine. Our target body we could just select up here, but we want to do body 1 of the back volume. Left click on that. And then our tool bodies, make sure that keep tools is selected, but on operation we want to make sure it says cut, and we can just select, we want to select the rubber foot. Do I have that shown? I do. So we can go into the rubber foot. You do it one of two ways. You go into the tree, expand the bodies, and then left click on the body of interest that you want to subtract, or you can do it visually. We'll just do it this way for now, and left click on OK. Great. So just to make sure that that actually worked, we can isolate the back volume, and we could see that the back volume has removed the rubber foot geometry, right? Because we only want the back volume to start up here behind the housing. So let's unisolate this, right click on back volume and then left click on unisolate. And we can hide the rubber foot. We don't really need that anymore. So we want to do this same workflow with the outer housing. So if we go to combine again, and it's kind of deceiving because the combine feature is also your subtract feature and your intersect. So just a pro tip there, that you can also cut objects with the combine feature. Tool bodies, we will select the housing itself. I don't know that that's selected. There we go. Gives you a nice little preview. Again, we want to keep the tool and select OK. If you don't keep the tool, it will actually remove the body that you're using as the tool. So if we, and maybe let's just try that. If we go in here and we don't keep it, now our back housing is actually gone. If you go into your housing component, you'll notice that there's actually no body anymore. So we definitely want to keep that. Edit feature, keep tools, and we want to keep that housing. Great. So I see a nice clean kind of operation here. I'd like to just extrude this all the way up to the top. We don't want any of this volume to be considered within the back volume. So we could select this bottom ridge here, hit extrude, and also hit the left click on the top of our cylinder and make sure that it's cut. But objects to cut, we don't want to cut the housing, so just make sure that the back volume is the only thing selected. So left click on housing to unselect it and then select OK. All right, so now we're going to start removing some of the components of interest that will not be part of the back volume, right? Our PCB is just taking up volume that could be used for the woofer, so we don't want to include that in our back volume for the speaker. So we'll do something similar, combine, target body, tool body, select the PCB, keep tools, select OK. Isolate, looking good. All right, unisolate. We want to do the same thing for all of these speakers as well. I'm not going to, I'll demonstrate how I'm going to do this for one of them, and then I'll let you kind of do it on your own, and I can fast forward through this tutorial on that part. But I'm grabbing the flange here, the surround, the basket, this little magnet ring, the magnet itself, and that should be it. And then it's keeping the tool automatically. Select OK. It should be about five operations per speaker. And let's just make sure it got that isolate, and it did indeed. So I'll go ahead and do that for the rest of these, and then we'll circle back once we get to the top woofer. It should look something along the lines of this. You should have a back volume that's around, let's see, this is a good, you can right click on body 1 and go to properties, and it'll show the volume here, 5,680 cubic centimeters, or cc is how we refer to that. So we'll click OK. We're just shift middle clicking to rotate. So we've still got some more work to do. Right click on back volume and select unisolate. We'll go back over here into section. Just do section 1. Again, I made 2 different sections here. I made a section on the front plane and a section on the right plane. So if you don't have that, maybe add another section for your other viewing plane. We're going to do the same thing here. For the top woofer, we'll do combine, left click, target body, select this top one, and then for tool bodies, we will select this guy, this outer basket, this flange, this surround, this lower surround, and all right, left click on the magnet and the ring, and select OK. All right, we're all good there. Right click on isolate. And we're just about good to go. Now, you'll notice we've got some volume at the top here, and then our surrounds need a little more. So I'll show you how we're going to do that here in just a second. Unisolate. What we can do is select this body, combine, and then for tool bodies, we can select all of these perimeters, and it should separate that this top body into its own. So this, and that, and keep it and select OK, and this should now be its own body. Hopefully it is. Okay, cool. So we got rid of that. We're just about there. This looks pretty good, depending on the audio, say, speaker that you're working with. The surround might look a little different. It could go in, and depending on the audio engineer that you're working with, they might want you to calculate back volume, say, only after the extent of this cage. But for the purpose of this example, we're just going to assume that it's everything below the surround, subtracting all the speaker components. That looks good. So I think the last step here for us is going to be to include this, and I've got a kind of janky way to do it, and if you guys have a simpler way to do it, definitely leave it in the comments below and I'll try it out. But what we can do is create a sketch on the front plane here, and then I'm just going to project, say, the bottom edge of this flange and then hit enter. And this is so we can create a center line at the midpoint of this axis. So if we just follow this all the way down until we see this center point triangle, and then make sure that we're at 0 degrees, we can use this as our center line, and then select and hit X to make it a construction. So what we'll do is we'll just do project, just take this profile, just left clicking all of these Inner profiles. Again, it doesn't need to be super perfect because, you know, 1 or 2 cc's off isn't going to make a huge difference in the speaker performance based off the size of the cabinet that you're working with. So we can be a little rough with this step. And actually, I got out of the sketch, so let's go back in the timeline here at the bottom and left click, and then left click or right click and then left click on edit sketch. So you can see this isn't a closed loop yet. So we'll just bring this down. To around here. Just doing something like this. And this should give us everything not interfering with the basket as well. I mean, maybe a little bit, but just bring it up a little bit. Okay. And then this sketch is not closed, so just do some lines, left click on these points and connect this whole thing. Again, this is just a quick and dirty way to get a close representation of this back volume. Okay. And then let's isolate this, right click on isolate and see where it's not connected. On some of these lines, I'm just creating construction so we can see where the loop isn't closed. So it looks like there's a break in here somewhere, right here. Nice. Cool. Okay. Nice. So we've got one enclosure, or one enclosed sketch, not enclosure. All right. So we'll finish. You can probably guess what I'm going to do here. Just create a revolve on the axis, select this axis, but we are not going to, oh, you know what? We need to make this a little larger actually. Cancel. Just drag this guy down a little bit. You can always go back and subtract the basket if you want to. And maybe for the purpose of examples working forward, you could do this step at the beginning and then subtract, which would probably be a better workflow. Revolve, it's still not quite there. Just down a little further. Again, we just want to make sure that we're connecting this with the max curvature over here. Revolve. And we want to join. Boom. Okay. Looks pretty good. Now what we'll do is this revolve, what I'd like to do is pattern this. So go into create, left click on pattern and go to circular pattern, and on the axis we could just select the outer side or surface of the cylinder here and then hit 4, and then it's going to just pattern it automatically on those speaker locations because they're all symmetric for us. Great. And that's it. That's our back volume. So in order to calculate it, what you do is actually we need to hide these bodies too because they're outside of the surrounds. Oop. Oh, that's interesting. For some reason it didn't separate this into let's go back here. Let's hide this body 3 first. Edit feature. And wants to join that. So what I'm going to do, I'm just going to create a new body for this. Select OK. And then pattern those new bodies. Okay, and then what we can do is go to combine again, target body, cylinder, tool body, the surround that we just made. We can do join, hopefully, and it doesn't. Actually, we don't need to keep tool, so right click, edit feature, don't keep tool, click OK. And that should be good. Okay, and now we can, let's get out of this analysis for a second. Now we can combine all of these together. Don't keep tool, boom, combine. Oh, and honestly, I should have just done all those in one step. Sometimes if you're doing the combine feature with many different component bodies, it gets really confused, and that's why I did it separately for all the other speakers. But try it yourself. Let me know how it goes. Now we can go to the body, the back volume body in blue. Right click on that. Left click on properties. And we're at what, 4,985 cc, or cubic centimeters in back volume. All right, that's it. Thanks so much for watching, everyone. If you guys found this video helpful, please like and subscribe. Leave any comments below. I'd be really curious to understand what your back volume calculation workflow looks like, and I'll see you on the next one. Thanks.